Okay, we're going to go ahead and do some practice genetic problems. Now you'll probably notice that my picture is not at the bottom because I'm going to be writing on a tablet as we solve the genetic problems together. So you should have out this worksheet called Monohybrid Genetic Crossings. Notice the keyword crossings, so go ahead and get that out. What's not on your sheet, I put some keywords here that we covered in the initial Intro to Genetics lecture as far as terms that we'll be using. Feel free, I encourage you, we'll do the first one together, pause, try doing the second one on your own and so forth, and then check your work. So that'd be great practice. It'd be a lot better, I think, than just watching me go through it and try to solve it. Hopefully this is review. You may have had this in school. Okay, so always read the directions first. So the directions say write the symbols and the parental cross from each. So we're going to build on this. Eventually we will be answering questions after we solve a Punnett square, but we need to get these basics down. So I always read through the problem. Homozygous dominant round seed coat, cross, that's what that X is, homozygous recessive seed coat, and it wants me to use the letter R. So let me go choose a color up here. Maybe. There we go. Okay, so we're going to use the letter R, and we're always going to have a capital for dominant and a lowercase r for recessive trait. So I can read and determine which is dominant and which is recessive. So dominant round. So I know a capital R is round. And homozygous recessive wrinkled. So my recessive trait, or lowercase r, is wrinkled. Okay, so there are my symbols. Now my parents. And I'm going to refer to these terms over here, homozygous, heterozygous, pure, and hybrid. So my first parent, homozygous, dominant, round. Homozygous means the same letter. So my symbol for round is a capital R. So I'm going to have two capital R's. Remember, everything occurs in pairs. Crossed with homozygous recessive wrinkled. Again, homozygous, same letter, recessive wrinkled, lowercase r, so I'm going to have two little r's. And that's all the directions ask me to do. Because if you don't have these parents set up right, everything from the Punnett square to answering the questions would be off. So that's very important. Okay, so let's go to number 2. Next I have symbols and parents again. Hybrid round seed coat crossed with a pure recessive wrinkled seed coat. So my trait is seed coat. I've got my contrasting alleles, round and wrinkled, and it wants me to use the letter R again. So big R, little r. And hybrid round, that doesn't tell me if it's dominant or recessive, but if I read on, I can see that it says recessive wrinkled. So wrinkled is recessive, so that's my lowercase r, so let me write wrinkled here. And so then my round has to be my dominant. So round. Okay, so those are my symbols. Now let me write the parents. First parent, hybrid round seed coat. So hybrid is the same as heterozygous, which means different. So it's going to get one of each letter, so big R, little r, cross with pure recessive wrinkled. Pure, same as homozygous, same letter, wrinkled. My symbol for wrinkled is lowercase r, so I'm going to get two little r's. So there's my parents. Okay, so that's number 2. Now let's move on to number 3. Hopefully you're pausing this and trying to solve it and then checking your work. Okay, number 3, again, symbols, parents. So I've got homozygous dominant brown colored hair, homozygous recessive white colored hair, use the letter B. So I need a capital B and a lowercase b. You notice I'm not switching letters. This is one trait, one letter, one capital, one lowercase. That's a common mistake. People switch letters. You can do that for dihybrid, trihybrid, etc. Okay, so hair color. I've got brown and white. Dominant brown. So it tells me this time. So that's going to be brown for my capital B. And recessive white, lowercase b. Now my parents. homozygous dominant brown. So homozygous, the same letter, brown, so I'm going to have two big B's. Cross with homozygous recessive white. White, homozygous, the same letter, so two little B's. You're going to start seeing that the only way you can have a color exhibit or a trait, if it's recessive, it has to be homozygous recessive. That's the only way you can have a trait exhibited if it's a recessive trait. So make sure you remember that when you do future problems. Okay, number 4. Heterozygous green pod crossed with a homozygous recessive white pod. So I've got pods, green, white, wants me to use the letter G, so capital G, lowercase g. Okay, heterozygous green, that doesn't tell me if it's dominant or not, so let me go to the other one. Homozygous recessive white. Okay, so white is recessive, which is my lowercase g, and green is my dominant. Now, just because up to this point I've been listing the dominant allele for the trait first and the recessive second, that's not always the case, so make sure you always read. I will have a problem on homework where I switched around, so pay attention to that. Okay, so my first parent, heterozygous green. Heterozygous means different letters, so I'm going to have a big G and a little g. One of each letter. Homozygous recessive white. Like I said in the previous problem, the only way it can be homozygous recessive, it has to be two little g's. Okay, and then our last one for symbols and parents. Now it's worded a little bit different. I've got two hybrid tall pea plants. Tall's dominant over short, and it wants me to use the letter T. So let's go ahead and put our symbols. And tall's dominant over short, so it just happens to lay that out for me. So there's tall and short. The more you do these, you're going to start figuring out which is dominant, which is recessive. Okay, and then it tells me I have two hybrid pea plants. So it's hybrid crossed with a hybrid. Hybrid, remember, means heterozygous, so I'll have one of each letter. So my first parent will be big T, little t, and my second parent will be big T, little t. Okay, so hopefully you now can confidently do symbols and parents, because like I said, if you mess up here, everything else after that's going to be messed up. Okay, number 6. Now, let's go ahead. They've given us the parents. They've given us the symbols. Now let's fill in the Punnett square. We're going to put one parent here separating the alleles and one parent on the side. It does not matter which goes where. My professor, you're going to see a pattern. My professor always made us do the first one on the top and the second one on the side. But you'll get the same results. So I just been beaten into my head to do it this way. So let's separate the alleles. So here's big B, big B. So big B, big B. My second parent's going on the side, separating the alleles, big B, little b. Now all we have to do is pull one down and one across. So big B, big B. This one's coming down. This one's coming across. So big B, big B. Now, our last lecture, I had said always put capital first. So I'm bringing the big B down, listing capital first, lowercase b second. Do not write it the other way. I will count that wrong. And then big B, little b. Okay, let me switch ink here. Okay, so we're going to look at genotype. Geno is the genetic makeup. So I wrote these out for you. If it helps you to write it out every time, then go for it. Okay, so I've got big B, big B. I have 4 possible offspring. How many would I have that have that combination? It has to have that combination. I've got 1, 2. So 2 with that combination. Next, how many have big B, little b? 2 again. My third possibility is 2 little b's. Well, I don't have any, so that's 0. So my ratio, my genotypic ratio is 2:2. I do not write the 0, it's implied. How you can check yourself, this should equal the number of offspring. So if it's a monohybrid cross, it should always equal 4. Okay? So let's look at the phenotype. Now let me switch here. I'll use a highlighter this time. Now, pheno is a physical characteristic. What do they look like? So to remember this, we're going to look at the first letter of each offspring, the trait. So I'm going to look first letter, first letter, first letter, and first letter. That's all I look at. That's what they're going to look like. Okay? Go back to black here. Okay, so my phenotype is brown. And I said that my brown color is a capital B. So how many, I'm just looking at what I highlighted yellow, I will have 1, 2, 3, 4 that will be brown. I don't have any that are white. The only way it can be white are 2 little b's. I don't have any. Okay? Remember, this is phenotype, not geno. So I only look at the first letter, pheno first, geno both. So I have to have at least 2 numbers for a ratio. So in this case, I will put the 0. Okay? 4 to 0 ratio. Add those up, 4 offspring. Now, common ratios you're going to see doing monohybrid crosses. We've got 2 to 2, 4 to 0, 3 to 1, and 1 to 1. So that can show up those in either of these or both. Just depends on the situation. Okay, let's go and do our last problem. Okay, so let's write our first parent. Again, I always write it on the top. So big R, little r, big R, big R. So first parent on the top, second parent on the side. Let's go ahead and fill in the Punnett square. After a while, these become fun. Okay, big R, big R, big R, little r. Let's go ahead and change a color here. Let's make it red. Okay, so big R, I've got 2. Big R, little r, I have 2. I don't have any that are 2 little r's. My ratio is 2 to 2. Okay, pheno, big R round, so if I look at the first letter of each, I have 4, wrinkled 0, so my ratio is 4 to 0. Well, that's exactly what I had in my last problem. But let's say, for example, that you wrote it down wrong. Okay, so let me get rid of this. Okay, so let me go back to a color here. So let's say I accidentally put big R, big R. I wrote it down wrong. Okay, so let me go ahead and fill these in. Now, that's not going to change my genotype. It's still 4-0, but it will change my geno. So big R, I now have 4, not 2. I don't have any big R, little r, and I never had any 2 little r's. So now my ratio is 4 to 0. You can see one letter will affect half of my Punnett square and half of my answer for genotype. Okay, if I was asking for geno and pheno. So very important, you double, triple check those parents before you proceed. Make sure you've got it written down right. Okay, so that's our practice for monohybrid genetic crossings. Feel free if you want to go back and look at any. Okay, thanks a lot.